Hello everyone, and welcome to today's math lesson with Everyday Seminar. First of all, let's go over the solution to last week's question. The question was, subtract the vector v from the vector u, which is basically the vector u minus vector v. Solution to our answer. So what we're going to do first is we're going to put u here. And what we do with v is we reverse the direction. So this is negative v. V was perhaps going this way. So negative v, we go the other way. We change direction, and we go that way. We take that, put it on top of u, and we get the resultant vector, okay, from the initial point to the end point. So this can have two lines. That's the resultant vector of u minus v. Straightforward. And you can do it in this form as well, using the coordinates. But this method is much easier, okay? Just change the direction. Okay, let's move on. So today's topic is, again, we're dealing with vectors. We're moving to the next step. You remember the last lesson we did addition, subtraction, and now we're going to be doing the multiplication of vectors. Okay, also known as the dot product or the inner product, or sometimes the scalar product, or sometimes a scalar dot product. Okay, let's move forward. So our key terms for today, vectors, as you all know, the dot or inner product, scalars, magnitude, direction, geometrically, parallel, orthogonal, perpendicular, and polar notation. Okay, so the introduction to vector multiplication, basically a vector multiplied by another vector. Two ways to do this, two possibilities, scalar or dot or inner product, a dot b, okay, we call that a dot b. Now this is useful where a scalar or a magnitude result is wanted from the product of two vectors, okay. The next one is a vector or cross product, a cross b. Now this is useful where a vector direction, okay, result is wanted from the product of two vectors. Remember, a vector is based on, it's made up of two parts. We have the magnitude and we have the direction. Magnitude, maybe what, 5 or maybe 20 centimeters, that's the magnitude. Direction, east. Okay, two parts, where it's pointing and how long the line is. Okay, let's move on. So, let's move on to the dot product of vector multiplication. Now the formula for the dot product a dot b is the absolute value of a. Remember, this means absolute value, okay? So if a is equal to negative 3, the absolute value of a equals to 3. An example there. So the formula for a dot b is absolute value of a multiplied by the absolute value of b multiplied by cos theta. Now, what is that theta angle? So this angle is measured counterclockwise from the x-axis. So this is the positive x-axis. Whoa. So this is positive x, okay, plus positive. Remember, that's negative x here. So from positive axis, we go counterclockwise. That's clockwise, counters the other way. So from here, going that way. And that angle here is theta. Now, note that cos 90 degrees is equal to 0. So for perpendicular vectors, the dot product is 0. Example, force. Remember in physics, we have two vectors here. Force times distance. The formula is equal to FD, force times the distance, cos theta. See that angle? Okay. Remember, if you have a person pushing a box, sometimes this person is pushing up that way. He's not pushing straight, but he has an angle going that way when he pushes his hands. So we take that angle and we can calculate the work. Okay? Okay, moving forward, the vector multiplication, dot product. A few things we want you to remember. Special properties. A dot b is the same as b dot a, okay, which is also the same as 2 times 3 equals 3 times 2. Times 3 is equal to 3 times 2. A dot a is equal to a squared. And finally, a dot b is equal to 0, especially when we have cos 0 degrees, which equals to 1. Notice that where a and b are orthogonal, Orthogonal means they're equal to 180 degrees or a straight line. Now, thus, therefore, if you look at this picture here, we have I coming this way. I times I, that multiplied by itself is equal to 1. Okay, notice that that's a scalar. It has magnitude. It's a value. It's not a direction. I times j, I multiplied by j that way is equal to 0. Okay, notice how they're on the different axes. Okay, these are special cases. Let's move on. Okay, again, the dot product, vector multiplication. Multiplying two vectors sometimes gives you a scalar quantity, which we call the scalar or dot product or inner product, as we mentioned earlier. Polar notation, consider the two vectors, absolute value of A, the degree of theta, and we have B, the absolute value of B over here, and we have theta here, theta 2. The dot product between A and B produces a scalar quantity. And the scalar, the magnitude of that scalar is defined as, remember we mentioned it earlier, absolute value of A times the absolute value of B. So the length of that line multiplied by the length of that line multiplied by cos theta. Now this theta, what is it? So theta is a net angle between the two vectors, net angle. So net angle is also equal to the difference, as shown in the figure. So here it's going to be this one, 0, 2, theta 2, minus theta 1. And that'll be this theta here. Okay? As we'll show you shortly. So here we are on the same problem, the scalar dot product. So say for instance, the absolute value of A is 12. So maybe that's what, 12 centimeters, just imagine. And we have the angle 30. Okay, that's 30 degrees. Theta down there is equal to 30 degrees. Now B, the length of the line B is 5. Okay, so this A, we have the magnitude of a 5. So the absolute value of A equals 5, and the degree is 30. And B, we have the absolute value of B is 5. Sorry, absolute value of B equals 5. Notice that this is not 5, this is 12. Notice that the length of A is 12, the length of B is 5. See how A is longer than B? A is longer than B, that's why 12 is higher than 5. And we have the angle 65. Beta equals 65. The angle. So that's 65 from here to here, and 30 from here to here. Therefore, 65 minus 30 equals to 35. So our cos theta, that theta will be 35 degrees. Now, as we've done here, we multiply the absolute value of A, which is 12, multiplied by the absolute value of B, 5, multiplied by cos 35, okay? And the answer, 49.15. Notice that the answer is a 49.15 is a magnitude, okay? It's a scalar. It doesn't show direction. In unit vector notation, looks a little different. Consider this. Here's another rule to remember. When you have something like this, what you want to do here, to multiply that by that, you just take the x components here, put them together, okay? And then you take the y components, put them together, and the z components, so forth. Okay, let's move on. So the scalar dot product, we have two examples here. Let A equals 3i minus 4j minus 5k, and B we have there. Therefore, A dot B, we take the two I coefficients, put them together, the two j coefficients, put them together, and we get a final answer of negative 37. So what is the significance of the dot product, or what does it mean? Okay, what does it mean? What is this? Why is it important? We'll show you shortly. So the significance of the dot product, in this figure on the left, vector B has been split into two components. One parallel to vector A, okay, parallel means the same direction, and one perpendicular. So one that cuts A at a 90-degree angle. Right. Not percentage, 90 degrees. Notice that the component parallel to vector A has a magnitude of absolute value B cos theta. Okay? See what we've done here? So when we want to calculate that value, we have an imaginary line, not real, and then we take that value, So all you have to do is multiply that cos with theta, and you get the value here. Okay? Therefore, when you find the dot product, the result is 1, the magnitude of one vector, in this case absolute value of A, absolute value, and 2, the magnitude of the second vector that runs parallel to the first vector. So you got that one, and you have that small, you got the value of that line there, okay, this line. And that is where the cosine comes from. That's why we use cosine. Okay, you remember our trigonometry lesson, and that's about it. Finally, today's quiz, the dot product. Very simple question, what is A dot B? Vector A equals 2i, vector B equals I plus j. Notice how there's no j in vector A. Next week we'll go through the answer. Thank you for joining us today with Everyday Seminar. Have a good week.